how much time I have? Tell me, because I'll wind up in that. I'll follow as a teacher. Okay. 30 minutes. Okay, I'm not a sir. Okay, to you. Okay. Thank you, because sir brings the gap between the people. Okay, that's my usual thinking. Thank you, Dr. Santosh, and I might have not been here without your invitation. Thank you for inviting me. And this talk is very, very important to operate wherever we talk. But I'm not just saying I talk, we talk. We are a group of people. We believe AM word has been misused so badly. Okay. AM cannot be just used alone. It has its own limitations. Everyone knows it. Okay. Publications may come, everything may come, until unless you use the judicious use of AM is not going to be a right tool. That's what, at the same time, that Santosh was introducing me as a metal forming person. Okay, those days when I was writing my code in early days. After that, I moved away a lot. Okay, but the thing is, here we combine both once again. But I will not be able to show, because some of the videos I will not be able to show in this PDF, or some animations I cannot show. Okay, our work mostly it got clubbed into one. There are 4 or 5 slides clubbed into one slide. You may be able to see one of them. Okay, so that's the bad part of the thing. Okay, so now these are 3 slides here. Okay, into this, where the animation has gone. See, you all know that manufacturing processes are classified into subtractive, additive, and formative processes. But you all know each one has their own game. But when it comes to reliability of the component, always the formative is preferred. Okay, be it aircraft gear or be it where whatever the critical component comes. Okay. Now, when it comes to additive, it has its own disadvantages, advantages, and all that. So, all those plugged into this slide. The thing is, we have to use the judicious combination of these processes. We cannot say that I am a casting guy, I am a forming guy, I am a, until unless we combine them properly and then use the individual strength of each process, the way the teamwork happens. Otherwise, there is no point. That's what the meaning of all this work which I wanted to communicate. Okay, anyway, okay, now if you see today, okay, the world is changing, society is changing. I'm putting the context into the place. Okay, we all know the mass production, we all know the customization, but then today people wanted mass customization. It's not the customization, it's not the mass production, mass customization. Basically, ability to produce the single product with the same efficiency as that of the mass production. Okay, that becomes a mass customization. Okay, so now you can clearly see that the guy is breaking his head how to make, but the thing is that is possible only when the judicious combination of the processes are used. And one more thing you can clearly see, most of the times you will find where from I have taken this. Okay, now after 2000, you see this the later picture. We are thinking globalization, regionalization is also becoming, we all know, after pandemic, this is becoming more and more visualized. Okay, so that also you can clearly see. So when you are thinking of any manufacturing process, manufacturing is an integration of whatever the mechanical sciences which we learn, or electrical sciences, physics which we learn. It's an integration. Without a fluid flow, without a heat transfer, without a stress, show me a manufacturing process. We sometimes say that that's the problem with the manufacturing process. Sometimes we are not able to pull the students into the class because we go too descriptive. Okay. Now, is conventional out? Sometimes that's the impression some of the funding agencies, someone else gives. Okay, but it's not. But you have to be very clearly, judiciously use. I'm not getting into because. But thing is, how do you use? It depends on majority of these. Because I'm not saying these are only. These are the major ones. For strength, material selection, for complexity, manufacturing flexibility, part accuracy, residual success. You tell me, those who work in the additive manufacturing, which one among them is the additive is going to gain? Only the part complexity and manufacturing flexibility. And all other things, other processes have their own advantages. Okay. So, then how judicious combination or a better combination, hybridization can come into picture. That's another way of looking at it. Now, whenever we look at a manufacturing process, including additive manufacturing, okay, including additive manufacturing, without understanding, okay, that we cannot just understand the process, come to the optimal process. This is all you know. You all might have studied the Kalpakian book. There is a Kalpakian slides, not even my slide. Okay, from the net. Okay, so including all these things. But now when it comes to layered manufacturing, and this is actually the writing is of Prof. Amitabh Ghosh. I still use that because there is an animation in it, which is not coming because we taught course together at IDK. I still use his handwriting for that. He is giving a keynote in the evening to all of you. Okay. So it can be defined as a group of techniques used to quickly fabricate the scale model or a part or an assembly from a 3D computer-aided design data. That's it. There's nothing else. But what additive manufacturing concept uses, this can be taken to multiple other processes. And a judicious combination of all of them will be very, very useful. Okay. Now, many of you know this. There are many, as my talk is on metal additive manufacturing. Okay. Metal additive manufacturing. So, the purpose is just to list because you have many other processes like binder jetting, metal particles can be binder jetted, sheet lamination, friction surfacing, powder bed fusion, and direct energy deposition. And many of you work around these two processes, powder bed fusion and direct energy deposition. Okay. Now, powder bed fusion process also you know it because of the time limitations. I am not going to get into some of the details which I wanted to emphasize. You all know about direct energy deposition processes. Even in the direct energy deposition process, energy source may be a laser, electron beam, or an arc, or whatever it is. It can be plasma, whatever it is. You can use variety of energy sources. And the raw material can be a powder, raw material can be a wire form. Both the things can be used it. Okay. So that's the whatever. But main thing is this needs also important. Okay. Whatever we do in manufacturing, zero emission, today if we talk about anyone, by 2030 we have to be carbon neutral society. We might be thinking, but the thing is, whatever the simple thing which we do, we have to think in that direction. Am I adding carbon footprint? Okay. So now, you can clearly see, fourth one is a very, very important one. Okay. A responsible consumption and production. Okay. So basically, whatever the thing which you do, even if you can save 10% of energy, 5% of energy, 2% of energy in each component level, that adds up to huge amount. That's another important thing. So sometimes additive manufacturing is missed. Sometimes they say the energy can, but the thing is, if you calculate the energy from the credit to get, additive manufacturing is going to have a major footprint on the credit to get point of view. Okay. Now, whenever we are talking about this energy, sometimes aircraft doesn't consume much energy while making, but majority of the energy of the aircraft is during its life service. Okay. But similar, some products take the more energy during the fabrication, but not during the lifetime. Okay. So whenever we are thinking of this, by doing the proper manufacturing, selecting the manufacturing processes, one has to consider all the stages of the life cycle. By doing this decision at the initial stage, what is going to implicate at a later stage? That's also very, very important one. Okay. And another one today, buzzword is circular economy you are doing and combining to that. Okay. Now, when you do the circular manufacturing, this is the linear manufacturing part of it. This is a slide which I used from one of my collaborators, Professor Takata. Okay. So, this only is not the 2 hours, 6 hours, people call now 9 hours, but whatever it is, reduce the material. Indian culture used to be use whatever is necessary. That's what Gandhiji used to say even prior to that. Okay, but when we try to become westernized, things change. Okay, but it's not bad that we're getting westernized, but the thing is we have to combine the good of every side. So, whenever you are saying, let's say take an automobile, the product life might be over in 15 years. Do you think all the components life is over in 15 years? No. Okay. Now, many of the components can be repurposed to something, refabricated to something. You might not use the sheet metal's total metal possibility of it. You can reform that without going to the recycling where you are wasting the energy part of it. You can do the cold recycling. I am taking one part of the application. You can go into various things. Let's if you take any company and then its automobile designs, most of them they change a little bit here and there, but inside the structure will be similar. They say on this platform we are building 4 or 5 automobiles are built on certain platforms. Okay. So now how do you use that? Repurpose it, reuse it is a very, very important thing without crushing them and then melting them. Okay. So these are the the another one is 6R based closed loop material flow. Okay. Here, additive manufacturing helps. Whenever you are designing a new part, conventional manufacturing processes will not help you to produce whatever the geometry you want. But the additive manufacturing processes will allow you to optimize the part geometry using the topological part necessary wherever the material has to be present. Okay, you can deposit there. So this is where the things will be coming into the thing. The additive manufacturing is useful for this. At the same time, additive manufacturing cannot be used wherever you want it to use it. This is the point which I just wanted to communicate here. Now, hybrid manufacturing definition this is the first definition given by a group headed by an Indian in the CIRP, Professor Rajurkar. Okay, you all might be those who know the EDM, ECM, Professor Rajurkar. I think he's an alumni of this place, if I remember correctly, right? Okay. Rajurkar, okay. His definition was, in the CRP, you can clearly see that, simultaneous and controlled interaction of process mechanisms under energy sources, tools having a significant effect on the process performance. That's the CRP, those who know that. Okay. But then there are many narrow definitions, there are many open definitions. But here, you might have not paid attention. Simultaneous and controlled. Because he was working on ECDM, combination of combined non-traditional processes at that time. Simultaneous, and it's not necessary, they don't have to be simultaneous when it comes to hybrid health. Okay. The other one is narrow different process mechanisms to be used in the same processing zone. It's not necessary. Okay. It doesn't have to be that narrow. And then the other one is 2 or more established manufacturing processes into combined setup. Okay, I will show you Professor Karunakaran of IIT Bombay what he has done. He has recent paper which he has published. 7 different processes can be performed in the same line along with additive manufacturing. But this is put by me, but the thing is by thought of process by taking all the definitions together. Okay. A synergetic combination between the processes is very, very important. Okay. Of 2 or more different processes to overcome their individual limitations. Okay. And take advantage of their combined strengths. That's the very, very important thing. We can only do that when we understand each and every manufacturing process properly. Okay. Now, to produce components more efficiently, okay, and eco-friendly, that means more resource saving. What? Resource saving. So, Professor Santosh Kumar, tell me 5 minutes ahead, I will conclude whatever it is. Okay? Okay? Yeah? Yeah. No, I will do that. Okay. Now, there's another thing because I wanted to push this concept into the minds. Okay? Now, hybrid technologies, I am talking only metal additive here now. Okay? Are gaining importance to widen the scope of the geometries enhance the process capabilities. Okay, but if you see, including DMG Mori, you all know DMG Mori name in the machine tool world. They combine the machining and additive manufacturing into one platform. There are many other machine tool manufacturers. Okay. Then mainly on the material removal. Okay. Now this is exactly where the deposition and removal takes place. Mainly removal is very essential for even achieving the proper surface finish. You all know from the additive manufacturing concept, you cannot make it zero layer thickness. Okay, you have to make it staircasing effect, which typically what we call it as. Okay, and this is anyway taken from one of the persons moving around. He is not here. Dr. Pokemon Pandya's thesis figure is this. Okay. Now, this is one of my colleagues who has done. He deposited the additive manufacturing injection molded mold and machined. This is in use to make the egg trace. My colleague Professor Surya Kumar. Okay. So now you can clearly see the components produced by using this combination of additive and removal processes. Okay. But even way back, I think this slide is on bullets. Okay. Yeah, you can see that that's there. We combined the combination of machining and that way back in 2003 for the polymer components to enhance the surface quality. Now, one more thing is whether it's a multi-pass welding, laser welding, or a wire additive manufacturing, or whatever it is. Okay, we are going to metal edit. Okay. Now there is a difference here. Whenever you do welding, only deposit the material in a groove, majority of the occasions. Okay. When you are depositing the material in the additive manufacturing, you deposit like this. The restraint on the material, thermal conditions surrounding them is different. Okay. So now, the best case, the thermal gradients will be very high here, but the thermal gradients will not be as high as that there. Okay. So now, if at all I put a pressure on you, a student, don't look this side, that side, your efficiency will go down. Okay. So obviously, but the thing is, you cannot be given full freedom also. Okay. So the similar thing, you have to play a role between these things. What sort of the constraint will cause what sort of the residual stresses, what sort of the thermal history and all that, but I'm not going to get into that too much detail. I have drawn and then I listed all of them. I will skip that. Even simple mechanics based explanation I have given when you put the constraint, and it is all simple secondary solid mechanics example which you see sleeve and this thing by putting a nut on the top. You all have studied that. Okay, a similar explanation. Okay, I'll skip some of this. Yeah. Now I'm coming to hidden, which we coined the word. Okay, is hybrid concept developed by combining deformation and additive. Okay, why deformation? We all know that when you perform the operation under the compressive stresses, okay, then the mechanical properties are much better. It's a very well known thing. That is why you sandblast the additive manufacturing component, you sharp pin the additive manufacturing component, that's why they change the residual stresses even today. Okay. Now, if you look at the literature, this has been happening in the last 10-12 years actually. If you see that, it's not today. This is my way of classifying it. Deforming the deposited layers, okay, deformation of the deposited component. You can do at layer level, you can do at the component level. Deposition of the deformed component itself. Okay. So, deposition of the deformed component. On the deformed component, you deposit some component and you deform that. Okay. But why did I use the idiom? Because there is a, see the thing, when we are pointing this word. Idiom means capable of completing challenging tasks by using tremendous adaptability. Okay. Agility, flexibility, adaptability. That's the reason why we find this word idiom. I think soon it will appear this word in ASME conference. Okay. For proceedings. Now, it's nothing new, friends. You can clearly see 2013, I was telling last 10-12 years. Okay. Now, people are depositing it. At the same time, in situ or following that, the people are rolling it. Okay. What will happen? Okay. So basically you are causing the deformation of processes, microstructure can be changed, thermal gradients can be created, and whatnot, everything can be possible. But the thing is, I cannot blindly do it, but there has to be a design for it. There has to be a design for it. Okay. Not just this, you can have thought very complicated way. This is also 2013, you can clearly see that. Okay. You can apply from the sides, you can apply the compression, you can apply from the top. Okay. They have come up with some thought process and then designed very complex things. I am not getting into the details. Okay. Now, what sort of roller should be used? This should be a groove roller, flat roller, what should be the groove geometry? All this can be worked out. Okay. So people have done that. To complete in time, I am skipping one of these slides. And now, if at all you build a wall and you do the post-built rolling or rolling after every 4 layers, rolling after each layer, people have studied how they will be. Is it necessary to roll after each layer or after 4 layers? All this has been attempted. There are advantages, disadvantages at some time. Okay. Now you can clearly see that distortions can be reduced to a larger extent. Okay. And favorable residual stresses can be induced into the component by using the proper rolling schedules. Okay. Now you cannot think this as a rolling of metal sheet. Okay. Although you are using the same concept, but here this is a very micro domain rolling which you are doing compared to that. Okay. That is the one. Now people have done all sort of things, vertical rolling of butt welds, vertical rolling of VAM things, side rolling of VAM, and then compared all sort of those things. And now they can clearly say that substrate distortion and substrate distortion under different rolling loads, under different various conditions, and you cannot choose whatever the rolling load you wanted. Okay, this can be estimated today by using finite element analysis. Okay, what can be done, and then can be validated. Now you can clearly see there is a metal deposition is taking place, compressed air flow is taking place like a short pinning. Okay, and people are using this. Basically, what you are doing in a sandblasting short pinning is nothing but you are deforming the material there, taking to the plastic level. Okay, so that's what exactly you can clearly see. And short pin component micro hardness is much higher compared to powder and as built additive manufactured component. So you can clearly see 1.5 times higher. Okay, so all this is possible today. Okay, now this is for the Karnakar's machine. Okay, the metal additive manufacturing, hammering, removal, 7 stations. Okay, at Bombay, this machine has been built by him, and then to induce. Okay, the things the way you want. And now you can clearly see some people are using, there is a deposition, there is a basically ultrasonic vibration or some other frequency vibration, frequency based, because you all know that when you use the frequency, the frictional forces and other things comes down, it has its own advantages we have understood in the various processes. Okay, so now I'll skip these results. Deformation of the deposit. Okay, the second level of it. Okay, now you see that those who work in sheet metal forming, some of them I can see here. Okay, then tailor welded blanks. Okay, but when it goes to the leather welding and all that, still uniform thick sheet has to be done. Non-uniform thick sheets, and then putting it at all, you cut into multiple things. The assembly of it and all that. But the thing is, at certain places you can even do that. And then multiple applications are necessary in that people are basically doing even the stamping application, other applications where it is necessary. You deposit where the thinning takes place, you deposit where the cracks takes place. That way they can enhance. Okay, now to reduce the number of stages, to save the energy. Okay, all those things people are attempting. These are all actually available in the literature. You can see 2017 that is go back from present. The similar thing people have attempted for variety of automobile components when the customization is necessary. Okay, mass customization is necessary to save the energy. This is the 2019 work. Okay, now people basically deposit a component and then produce by using the single point increment forming. Even Santosh works around that. Okay, and even IIT Hyderabad is one of the leaders in that in the world. I don't have any hesitation to say that. Okay. Now you can clearly see there is a problem here. See, he deposited, then deformed. But he didn't bother. When you are deforming, there is a variation of stresses, cyclic loading, and all that happens here. There might be a not proper bond between the deposited material and the original material. At what stage that should be done is also very, very important aspect. Okay. So now if you see that some of the customized applications, there is a conventional ring rolling, but today people do hybrid approach, directly deposit and directly take to the ring rolling at higher temperature. Okay, without that, then they are producing the components actually in industry. Okay, and the less number of components are necessary. To show all this, people have done a lot of work on titanium material. Okay, how this rolling in situ at micro level will help, and all this is there. Now you can clearly see that the single point incremental forming on the deposited components. Now, similarly on variety of things where the formability can be there. Now, IIT Hyderabad has plenty of additive manufacturing facilities, okay, and we have a center of excellence in the additive manufacturing and even advanced manufacturing. Okay. Now, you can clearly see these were all found before the center of excellence came. Okay. Now you can clearly see all this. Now, you see that this is where I am only showing which is published one, which is patented one. I am not showing the ones which are not published and which are not patented. Okay. So now you can clearly see how the bending at additive manufacturing can be combined, which direction one has to bend, complex components, and then even the machine is done. You can make the variety of the components using this. And now this is a patented one as well as the published one. And myself, where the rolling and all those things combined, bending also can be done. This setup has been designed, fabricated, built at IIT Hyderabad. Now, deposition on deform, I'll just spend. Okay. Now, let's say you need some component like this. Can you make it by using one process? No. Then actually what the designer thinks is, okay, I have to assemble this way, that way. Today, by judicious use of these two manufacturing processes, you can come up with a design methodology. But the thing is, you have to come up with the process parameters where the bonding between these are very, very good, sufficient. Okay. So now, the variety of the things, it's by combination of the variety of the things, just by one more thing. Today, whatever you do in additive manufacturing, are they planar deposition or non-planar deposition? Mostly planar. Okay. So the moment you go to non-planar deposition, and the people say I use for mold repairing and all that, that actually needs a non-planar deposition if you wanted to exploit properly. But we do planar deposition. That is why once again the strength at zone will be different. Now we all know when we do forge, the basic example which you have seen now, BTEC, connecting rod, we say the forging and then grain orientation. By depositing and changing the deposition direction, can't we control the grain orientation during the certification? We can do in the additive manufacturing to some extent. Okay? And then even by deforming in a local rigidity. Okay? So all that is possible, and then the algorithms developed, and now if at all you wanted such a component, even people have come up with these have applications in the various domains. Okay. Now, if at all you want to produce that component by forging, you cannot go for these thin webs and rips. Okay. Your topological approach, they use the combination of forging and additive manufacturing and then come up with proper methodologies. This being used, this very recent work, 2020 during the pandemic time from Europe. Now, the patented and published, that's what I'm showing. I can show the video. We have built two machines in DSIF. We are the first one to build in the world as far as that machine is concerned at IIT Kanpur when I was there. Okay, and then the bigger one also, ours was parallel with the Boeing Ford machine. Okay, that I had Hyderabad. We use the combination of DSIF and additive manufacturing. Okay, non-planar deposition. A lot of work has gone around. 5 papers are being written by a PhD student. That's I'm not presenting all the things here. The PhD student is going to graduate in another 6 months. He is writing those papers, and some of them are going to review. Okay, a lot of work has gone in. We can produce. Okay, now give the component. We go through the CAD, feature recognition, divide them into the features, which feature has to be deposited and which way. All those things. Okay, these are some of the initial attempted components. Okay, I'm not showing all the publications related work here. Okay. So, in summary, what I say is I'm on time. Okay. So, judicious combination of different manufacturing processes have potential to enhance product complexity, to enhance surface quality, to enhance mechanical properties, structural integrity, to reduce build time, material wastage, and energy consumption. That is a major one. With obvious financial and environmental benefits. That has to be applied. Now, without mentioning these names, I am not doing my justice. Those who have funded are some who have given me 1 or 2 slides. To whom some of the students were there. Okay, list. Okay, except the first 2. Most of them I learned a lot by working with them. Okay, that's the most enriching thing as a teacher. Thank you all. If you have queries, questions.
So please.
Otherwise, I am here up to 5 o'clock. You can invite.
That means you are not sincerely listening.
Or I am not.
Right.
Yeah.
So, particularly during this deposition, to reduce the fracture probability or the thinning effect, so there this delamination may also occur because if we are going to put a different kind of a layer, this kind of a thing. So first that need to be studied in paper, and there is also this heat affected layer who will be also affected there. So that also going to play some role in
Designing in the process design stage. I have not got into the details. Even if I am going in one layer, whether I am going into or out in, how the thermal accumulation is going to take place, all that has to come into the process design. Even obviously, what you are saying, one place I skipped it. Okay. Now, if you do the same deposition under the clamping condition, unclamped condition, the game is different. I agree with you because I have not got into all the details here, but these people have attempted. The literature is available actually. That's what I meant to say. Okay?
What happens at the
Joint of what?
food?
It is possible to get the strength not as close to that of this thing, but the thing is to solve the function. It's possible. Okay. See, when they do that, they are also using some sort of a in situ plastic deformation type of thing along with the rollers. So what I meant to say is, instead of using a well-known methodology, but well-known methodology serves the purpose as far as certain design aspect. But then certain geometrical features are not possible by using that. Okay, when you are going for a topology optimization and all that, you should exploit the additive manufacturing by combining the processes. That's right. AM cannot be used for the total component. That is overkill. Okay, that's what my point is. Yeah. And maybe that Dixit's talk is there. Because I don't want to.
Also, thank you for your information. Also, I want to when you refer the term non-planar deformation.
Deposition.
Sorry.
Yeah.
So in my understanding, what I'm getting from that word that even for non-planar deposition. At the time we are having the deposition on plane itself. So what are you actually referring by saying this non-planar deposition?
Now, when I take a particular component, okay, you know the additive manufacturing. First of all, I orient the component in which I wanted to deposit. The decision for orientation, okay. One of the experts is moving around. Polak is the one who has gone along with us. Okay, that right. Okay. Now, which orientation is better? Okay. Now, why I am doing that? Okay. This takes the maximum build time. This takes the lower build time. Is that the only constraint? No. Did I consider the strength part of it? Did I consider the surface quality of it? Surface quality was considered. The strength part is not considered. Okay. So what I meant to say is, but still the slices are horizontal to the machine base. Am I right? Whatever you have done. But think the moment you are depositing in a non-planar surface, okay, right? In the plastics, I have seen the papers of Professor S.K. Gupta, who has given the talk some time back. What they do is they deposit a non-planar substrate by using other additive manufacturing, and then on top of that they deposit the other material. I have seen Professor Satyendra Gupta's work on that. He has done some work on the FDM region, but on the metals there are one or two atoms. But the thing is, the moment you go there, what happens? Whether a laser deposition or an arc deposition, the variety of the forces will be acting around the deposited field. Okay. Now, when my torch is like this to the torch is like this to torch is like this, the bead profile is different. And now, when I am going to deposit within that layer, even if I consider that my layer is a towel layer, I understood your point. But the thing is, my torch thing has to change from time to time, instant to instant, depending on the normal condition. You might have done the CAD course, display surfaces, the local geometric conditions. Okay. On top, using that, it has to be changed. All that has to be worked out.
It's some kind of thing that we are adding one more dimension to the deposition. Like
it's not adding one more dimension to the deposition. We are basically coming up with a methodology where the resource efficiency will be enhanced. I'll put that. The resource efficiency. Resource to me, material may be less, energy may be less, the property may be better, all sort of things. Resource I am using instead of getting into individual. Yeah. Watch by now. Yeah. A long time back. Yeah.
We reached one day that videos and submissions. Where can we see?
You can sit with me sometime. But even I am not going to he has recorded the presentation without my permission. Okay.
I took to see.
No. Generally, permission has to be taken for recording. Okay. This is not a right thing to do. Okay. That's fine. I give it. You can sit with me. Okay. Or otherwise, you send me a Google link from ISM. Still, you are there, right?
Yes.
Yeah. So you can tell me. I can. Okay.
We will have a quickly group program. So before I will request to
I request our session chair to present the memento and shawl to our keynote speaker.
so
Friends, I might be talking some. This is how I have been trained, and I am a bit open. This is what happens with me while talking. I don't purposefully don't talk like that. And Dr. Geeta knows. She has long association with me. Vajpayee knows.
so manufacturing is a long journey. It does not come in a day. A lot of practices. So
Thank you.
Dixit is as well as Reddy, we had together in that those
Yeah, Dixit and myself, we work with the same supervisor. No, no, basic thing is, because when I conduct something, I take the permission, I take the signature of the person. Okay.